Hi Avanti, I think probably we can make a start here.
Sure. Am I audible? Hello. Am I audible?
Yeah,
Yep, yeah.
Okay. So, a very good afternoon to everyone. My name is Avanti. So, we'll be discussing today different charts in Tableau. Now, before starting with exactly charts in Tableau, we can have a brief discussion about why Tableau, why not any other BI tool. So, as per the worldwide analysis, there are two BI tools that are widely used overall. So out of the two, one of them is Tableau and the other one is Microsoft Power BI. So both Tableau and Power BI are data visualization tools. So when we say data visualization, so what exactly is data visualization? So before these visualization tools, people or the stakeholders used to analyze the data with the help of Excel sheets. Now, when we are talking about Excel sheets, I'm sure every one of us have handled Excel sheet in one way or other. So in those, we are basically using it for doing storing some data or storing some analysis, maintaining some records or maintaining some payments or other info for personal handling things. So in that case, when we are talking about Excel, so it is now when in Excel we are not able to show all the charts or calculations so much clearly and so much handy. So after the Excel, 5 years ago, wide usage of BI tools started, and Tableau is almost 5 to 6 years back. It has a boon in India and in US as well. So Tableau is a basically a US based company, and it is providing software to everyone. Now the best thing about Tableau is that it when you go on the official website of Tableau, it provides when once you download any of the desktop version, so it provides you 15-day free trial. And if you're a student and you have a valid identity card that is valid for this year 2021, then you can have 1 year of free subscription. And so mostly because of this, it is widely used. Calculations that are required for getting the desired outputs are also much easier in Tableau. When we talk about Microsoft Power BI, now mostly companies that are having Microsoft Power BI are those companies which are having license of Microsoft. So generally those companies prefer Microsoft Power BI. But when we are talking about data, like how much amount of data can Tableau handle and Power BI handle, so definitely this one goes to Tableau, because Tableau handles a very large amount of data than Power BI. And it is uh, I can say that having worked on Tableau, it is somewhat similar to Power BI itself. So today our focus mostly is definitely on Tableau. Now, when we are talking about visualizations, definitely we have to see something. So when we see something, in case of or in technical terms, they are nothing but representations, graphical representations, and here we call them as charts or graphs. So one of the basic charts or graph that is almost used everywhere in all visualizations is the bar chart. Now we all are familiar with this bar chart, whether we are in the visualization field, whether we are in the BI field, or we are not, but we are every one of us have already seen the bar chart and we have also used. So first chart, bar chart, is basically used for doing some comparative analysis. So when I say comparative analysis, so I want to see the I have a data and I want to see the distribution of or I and now for example I have a classroom of 10 students and I want to do an analysis showing which student have scored the highest in the past test. So I can have a bar chart showing the highest bar, which can show the maximum number of maximum marks of a particular student. So as you can see, the bar chart are used to compare the data across different categories. So in this instance, number of students is the number of categories, and different students is number of categories. And now when we are analyzing any charts, we have few concepts that we need to understand in Tableau. First one is rows and columns. So rows and columns is nothing but, when we draw a chart on paper, it is nothing but x-axis and y-axis. So when we are in this when you anywhere when you see rows and columns, you can refer to it as y-axis. So there is a ready-made option of selecting a particular, what we can say, particular chart when directly as a shortcut, and that we will see forward. And so when we build a bar chart, it looks just a minute. Yeah, so it looks somewhat in this way. So as you can see, I had referred to you as rows and columns. So here rows, that is nothing but x-axis, is nothing but subcategory. Now for doing this analysis, when you download Tableau from the Tableau desktop from the Tableau website, you by default with the software you will have some database. Now databases are nothing but data sources in Tableau. So here there is a very famous data source used in Tableau, that comes with the software, that is nothing but sample superstore. Now this sample superstore is having more than 10,000 records. So it is having a varied records, having some of the sales, some of the like sales, profit, discount, and it is having some alphabetical fields such as category, subcategory. So a superstore data, or like DMart or Big Bazaar, something like that. So that superstore data or a sample superstore comes along with this software. So in from that sample superstore data, I have pulled across a x-axis as subcategory. So I am having accessories, appliances, and 17 such subcategories on the x-axis or on the rows, and on the columns we are having sales across them. So as you can see, now initially if I, instead of this I would have made a table, so then we would have had difficulty to figure out which one is having the maximum sales or which one is uh, giving the poor sales. So when we do the same thing with the help of bar chart, it is very easy to recognize which is having the highest sales. Now as you can rightly see, the subcategory, that is phones, is having maximum sales, and the subcategory called as fasteners is having the minimum sales. So this is first most basic analysis chart, that is bar chart. Now when in industry, mostly stakeholders, now when I'm saying stakeholders, I'm saying audience, who exactly is going to view this dashboard, who exactly is going to see this chart, or who is going to make out the insights from this chart. So when I'm saying sample superstore, so maybe owner of that superstore, now if he decides that let me see the sales of fasteners, let me observe the sales of fasteners in 2021, and if it does not grow over 3024, now he sets a particular target. So for example, he has set a target of $5,000. So if he'll analyze this data in same data in, for example, say December 2021, and he can observe that my initial data or initial sales in 2020 was overall total 3024, and for example if we are doing the same analysis by changing the year as 2021, there he observes that the sales is around 5500. So then he can easily decide that okay, I am going to keep fasteners in the superstore. Now even otherwise, if the sales is at par with this, so for example in the year 2000, in two consecutive years, if the sale is somewhat consistent, then there is no use investing in fasteners or keeping fasteners in the superstore. So bar chart gives us a quick analysis of the values over different categories. I hope I'm clear. Let me know if there are any questions.
Yeah.
Okay. So this was the first chart that is most favored among all the audiences. Second one is the line chart. Now, as the name suggests, it is consisting of a line. When I'm saying a line, so it is nothing but a horizontal line that is divided. Now, it connects individual points individual data points in a view. So generally, when we are doing a line analysis, it can be up, down, zigzag line, or it can be a plain line. Now, the plain horizontal line suggests that there is a consistent value over different categories. Now, if there are some variation, we can say that there is some up and down in the uh, variable value. Okay, so it provides a visual sequence of values and are useful. So generally, line charts in Tableau are preferred whenever there is time series analysis. So when we are saying time series analysis, that means we can analyze sales, or we can analyze profit of, for example, let's say I am introducing a new product as let's say Redmi Note 9 Pro. This is my new product, and I'm deploy or I'm releasing this product in coming 2 months. So then I need to analyze what performance that product, or how much sale that product is making over a particular time period. Now in Tableau, time period can be distributed in multiple parts. So in that, for example, here in this line chart, as you can see, we are having x-axis as month, that is January to December. Now, we can even, when we distribute it further, instead of January, February, March, April, May, June, July, up to December, we can have 410. Now, as you can see, 410. So this 410 is nothing but weeks. So here hierarchy, there is a hierarchy like year, then quarter, then month, and finally the weeks or particular days. Like for example, if I hover over this, so day of order date, that means in the month of February and 2nd February, the profit that my overall profit was nothing but 2,932. Now this looks a bit cluttered, so I just want to, I don't want to analyze over different, I don't want to analyze day by day analysis. I just want to analyze month by month analysis. Then again I'll come back, and here I can clearly see that my maximum sales was done in the month of December, that is $43,000, and minimum sales was done in the month of January. So I have done pretty much a profit starting from 9,000 and going up to 43. So this superstore analysis or this chart shows that in a particular year, let's say for example, this is for 4 or 5 years together. So in from 4 or 5 years together, the profit started for 9,000 and it grew up to 43,000 till the month of December. But in between, you can see there was a hike, there was a drop in between. So variations can be easily shown with the help of line chart. Now, in this description, as we said, that line charts are generally simpler to use, or they are also called as trend lines, because trend, what is the way, way in which the, or what is the trend in which it follows a particular pattern, or so always you can see that in a line chart you will always see a time series, whether it is week, number of weeks, number of a particular day, a particular month, or it is just years. So similar to line chart, we are also having same thing like line chart. We can also see as area chart. Now, what is the difference between this line chart and this area chart? Nothing, just the 2 points are joined, or just the 2 points are filled with the help of area. But mostly area charts is used for is not preferred in the industries. Mostly we prefer line chart because it is much sorted. And uh, when we are talking about commercial dashboards, so dashboard is nothing but a view consisting of multiple charts. So when we are talking about a particular report or a particular dashboard, audience or the stakeholders do not appreciate an area chart because it is just filled up, and like it does not make any sense of using this filled up area. But for our analysis, sometimes it can be used, but mostly they are using line chart. Then next, I'm just going to skip Pareto chart for now because it is just a little bit advanced thing. I'm going to come back to this Pareto chart after a while. Uh, Next one is histogram. So as the name suggests, histogram is nothing but frequency of values of a variable bucket into ranges. So for example, I'm the same example I can say, like for example, how can I say? So there is a election poll, and in that election poll, it was observed that Joe Biden, when he was nominated, he received maximum nominations from the age. Like, I'm just making it up. It is nothing to do with the real thing. So for example, Joe Biden has received maximum votes from the age criteria of 60 to 70. So let us consider. So 60 to 70 is one of the bracket, or one we in this data visualization world it is called as bucket. So in that bucket, or in that bin, in 60 to 70 group, or in 60 to 70 age group bin, the Joe Biden is having maximum votes. So that buckets, or those buckets, so I can start the buckets right from 18 is the age from where we can start voting. So I can group the ages in the back brackets of 10 years. So 18 to 28, 28 to 38, and so on. So the range that is 68 to 78 is the range where Joe Biden has received maximum votes. So you can imagine in that way. So it is nothing but somewhat similar to bar chart, but in bar chart, as we can see over here, there is a gap in between two subcategories. So binder is an independent subcategory, and bookcases is an independent subcategory. These independent fields where they are not connected to each other are called as discrete fields. That means they are independent. They are not at all dependent or not at all connected to each other. Whereas when we are talking about histograms, uh, as you can see over here, so here what I have taken, I'm taken the same sample store, this complete dashboard, or this complete report is being developed by using sample superstore. So in this, so I can say that now when I hover over to this chart, I can see that quantity 0 and count of quantity 899. Now what does this suggest? Quantity 0 means from quantity 0 to 2, that means from range 0 to 2, 899 quantity or total people, total members are contributing. Or from in this range for quantity 2, the total count is nothing but 4811. So you can imagine this as the Joe Biden example that I said. So for example, 0 to 2, instead of 0, 1, 2, up to 14, we can say 18, 19, 20, and so on. So I can say that in the age group 18, total number of voters were 899. In the age group 19, the voters were 4899. So this is similar to bar graph, but the distribution is very much continuous. That means both the all the bars are totally connected to each other, and this kind of visualization or this kind of axis is nothing but continuous axis, wherein there is they are connected to each other. 0 to, I can say, 2, 2 to 4, 4 to 6. So these are nothing but different buckets. Now this 0 to 2 is one bucket, 2 to 4 is another bucket, 4 to 5 is another bucket. So these are nothing but buckets. Now, when we are doing visualization, these buckets are by default formed. Like when we create histogram, these buckets are by default formed. Uh, for example, if I'm having total, uh, for example, if I'm having a quantity from 0 to 14, that means the buckets are divided by 2. That means the size of each bucket is divided by 2. So if I'm having a count of 50, maybe the buckets can be divided by 4, or it can be divided by 3, and so on. Not just a whole number, the buckets or bins can also be divided in decimal number, 2.5, 3.5, 4.4, anything like that. So this computation is done by Tableau engine or Tableau memory, and this is done for the analysis. Mostly the histogram is also not a favorite choice in case of charts selection. Next, we move on to pie chart or donut chart. Now we can see that pie chart or donut chart is so as the image pie wherein, sorry, hello.
Yeah, yeah, Avanti, go
Uh,
ahead.
can you see my screen?
Yeah,
Okay. So pie chart or donut chart. So we can imagine a pie, or we can imagine a not. We are Indian. We are mostly instead of pies, we are mostly used to eating a pizza. So you can imagine pie as a pizza, and you order something a pizza online, and you get a pizza. So we are just uh, dividing that pizza into triangular shaped pieces. So each and every triangular shaped piece is nothing but the slices. Okay, and these slices can be analyzed with the help of visualization. So for example, uh, when we are talking about pie chart, so in this pie chart, mostly when we are using pie chart, so for example, I am having, in case of India, I am in the India country, we are having 4 directions on the map: east, west, north, south. Okay. Now this sample superstore is a US sample superstore. As you have also observed, the sales or the numbers are in terms of dollars. They are not in terms of INR or rupees. So similarly, the this data, instead of east, west, north, south, the regions that this superstore is considering is east, west, south, and instead of north, it is considering as central. So the total number of profit. So in this chart, we are analyzing the total profit. So generally, pie charts are used when we have few categories, and that can be visualized. Now you can imagine, instead of these 4 regions, if we would have 8 regions, how cluttered the graph would have looked. So generally pie charts, or effectively donut chart, it is nothing but the same thing. Pie chart and donut chart, the only difference is that donut is having a empty circle in between. That's it. Just analysis wise, selection wise, pie chart and donut chart is somewhat similar to each other. So as you can see, the 4 regions are having showing, when I'm hovering over it, shows the profit. So region west, the total profit that region west contributes is nothing but $108, and percentage of total profit is nothing but uh, the share of west region out of total profit. So this calculation is done by profit of west region divided by total profit into 100. So just the percentage of that total profit of west region is found out. So generally when we are doing pie charts, we don't put numbers like dollar like dollar 39,706. When we are dealing with donut chart or pie chart, we talk in terms of percentage. What percent is this section? What percent is this section from the total of whatever measure we are using? Okay. Similar to this pie chart, we are having a donut chart. So when we are talking about donut chart, as I said, donut chart is nothing but a sister chart of pie chart. Just there is a empty circle in between, which we can show anything, whatever we want. So here, to make a more sense, I have considered the total profit. That means profit made by all the regions together is shown in the center, and out of this profit, the maximum share we can see has done by the west region. So 108,418 is the profit contributed by west region, and it makes out, or it comes out to around 37.86%. uh, uh, is it okay? So do let me know if you have any doubts. I'm going to stop here for a minute or two. Are we on the same page? Let me know if we have any doubts. Hello. You can ask me any question, no problem.
Clear with this much part, Avanti.
Sure. Thanks a lot. Okay. So next, let us move on to another chart that is nothing but tree map. So what is a tree? Tree is nothing but a trunk, and to that trunk there are multiple branches. So those branches are nothing but part of that particular trunk. So imagine a tree with a trunk and number of branches. So those number of branches can be of any shape and size. They are not symmetrical. All the branches are not of same size. So similarly, in case of tree map, so use tree map to display data in nested rectangles. So for example, a huge tree. So a block is nothing but a huge tree. The small branch is nothing but a small part. So for example, this is nothing. So you can better analyze with this chart. So these are all the subcategories that we have seen in the bar chart. So as you can see, from this end to this end are nothing but all this complete block in all shows the total subcategories and the total profit ratio. So when I'm talking about profit ratio, I'm just finding the ratio of sales divided by profit. So what is the total sales divided by total profit for a particular subcategory? So as you can see, the colors are differentiated from red to green. These are the color palettes that are already available in Tableau. You don't need to search for a particular color. So I have intentionally used this color because green color, now our first instinct is red is nothing but something to look out for. For example, when we see a red signal, we stop our bike or our car at that particular signal. Similarly, when we are seeing this red part, as you can see, this is a problematic area because the subcategory machines is having profit ratio 2%. That means the sum of sales divided by that means the sales divided by profit ratio is nothing but 2%. So I need to keep a close watch on this particular subcategory, that is machines, which is showing minimum profit ratio. And opposite to that, when I'm looking at the greener area, it is nothing but somewhat we can say that it is pleasant, or we are just happy to see the green color, or we are pleased to get the positive results. So we can say that red and green combination colors are nothing but used to indicate the positive and negative results. So when I'm seeing red, it is showing me somewhat problematic area, or the area to look out for. And here I can see the darkest shade of green is showing for the labels. Now, as you can see, the percent or profit ratio for labels is the highest. So effectively, the size of this block is the maximum, as well as the color of this green is the darkest among all the green colors that is surrounded by it. This tree map is also called as part to whole relationship. That means this part is having a relationship with this whole chart. What relationship? It has the maximum profit ratio. Similarly, this part is having relationship with the whole portion. Same what relationship? It is having minimum profit ratio. Now all the subcategories that are there in between, they are having somewhat varied profit ratio. So after the highest sale profit ratio of labels, we are having second highest profit ratio as paper. You can see that there is a slight shade change in this green color and this green color. So as we go from darker shade of a color to the lighter shade, it shows that we are going from highest value to the lowest value. So here in case of green, we are going from darkest, that is 44%, to the lightest, that is 24%. But in case of red section, that is a problematic area, darkest section should uh, catch your eye, should be caught in your eye first. So we are giving the darkest color to the most uh, to the least value. So that's why the darkest color is given to machine, and the smallest size of block is there for machine. Now as you can see, we are not able to see, like this block is not written machines and 2%. Why? Because as you can see, the machine is the large word and it cannot fit in this bracket. So Tableau decides, okay, I'm not going to show this word, otherwise it will overlap with this text. So generally it is not suggested to show this overlapping text. That means if it shows machines till here, the readability will it will get affected. So generally the small portions of heat map, tree map are not visible, or they are not shown because it may overlap with the neighboring fields. So the darkest color and the smallest size is the least profit ratio option. Second is a little bit lighter than this is 8%, and the chairs and the size of this is more than this block. And similarly we can go around to highest is the appliances with 17%, which is having the least which is having the lightest red color of this red section. So am I clear with this tree map? Is it fine?
Yes.
Yeah. Uh, I
Okay,
have one question, Avanti here.
sure.
In which scenario should we go for tree map?
So when we want to show one to whole ratio, so for example, I want to show a particular, I want to analyze two things. For example, I want to show sales, as that is one of the major. Now when I'm saying major, I'm saying quantitative field. Quantitative means something that has some numeric value. So when I want to compare two numeric values, I can use tree map. One numeric value I can use as color differentiator, and one other numeric value I can use as size differentiator. So for example, sales in color, that means highest sales will show the darkest color, sales show the lightest color. And if I'm putting profit in the size of these blocks, the highest size means highest profit, and lowest size means like smallest size means lowest profit. So in those scenarios we can use the tree map. uh,
Okay. Thank you.
okay, yeah, no problem. Okay. So the next plot is nothing but a scatter plot. So this scatter plot is used to visualize relationship between numeric variables. So as we are already discussing, the visualizations is nothing but relationship, or visualizations are built on x-axis and y-axis. So any chart that is distributed in between the x and y axis or in between the rows and columns is scatter plot. Now scatter, the word scatter means what? Spilled over. Now if we have a bunch of, say for example, marbles in a box, and accidentally that box opens in a, like we have a box filled with 50 marbles, and the box opens from the beneath or below area. So in that case all the marbles fall on the floor and they are scattered around that particular area. Imagine that scenario. Similarly, scatter plot is also in the same way, as you can see. Now here you can analyze this as the marbles that are fallen beneath. So these marbles, these scatter plots are nothing but dots, or any shape you can take, whether it can be square, it can be star, it can be plus, minus, anything. So as the description says, it is created by plotting the values of numeric variables as x and y coordinates in a Cartesian plane. Cartesian plane is nothing but this particular area, the area in between where the graph is plotted. And it takes at least one measure in row shelf and one measure in column shelf. So one measure or one numeric value that is to be taken on the x-axis, and another numeric value as is to be taken on the y-axis. So sales and profit are the two numeric values that are taken on x and y-axis, or rows and columns. And when we are saying hovering over to this block, now one point can show two values, one for sales and another for profit. So generally when we are plotting a graph, x-axis versus y-axis, you all know that x-axis is always an independent axis and y-axis is dependent axis. So values are going to vary accordingly. So the farthest point that shows maximum profit and maximum sales, and the nearest point. Now when we are going to use this, so for example, as I'm having a product as let's say Maggie is introduced in a particular shop in my nearby area. So that shop is a new shop. We don't know how is the choice of food that is accepted by people around. So we don't know how the sales is going to be for Maggie. Like in some places, Maggie is consumed maximum. In some areas, it is consumed minimum. Like people don't prefer, families don't prefer Maggie, but the bachelors, they cannot cook by themselves, or they don't have enough time to cook by themselves. Definitely, they will have preference towards Maggie. So that shop is not able to decide whether to continue keeping Maggie or to bring more Maggie packets. So initially that shopkeeper does, he keeps 10 packets of Maggie. He sees how the sales is for those 10 packets, and then he decides, okay, now these 10 packets are sold in 2 days, definitely I'm going to buy 50 packets next time. But 10 packets are taking 10 days to get sold. It is of no use to buy. Now he will not totally reject buying Maggie or keeping Maggie in his shop, but he will keep it in minimum quantity, and he will invest in a product that is sold maximum, or that is favored more than Maggie. So in that case, now here Maggie is to be analyzed, or the sale of Maggie, or the shopkeeper has to analyze two things. First, the total sales, that is the total quantity or total amount of Maggie that is sold, and what is the total profit made by Maggie. So if in the area where there are multiple colleges or where there are multiple hostels, I can say that this point can be achieved. But in a residential area where there are families, I can say this point is achieved where the sales is also minimum and the profit is also minimum. So I want to analyze both the things, sales as well as profit. Now this can also be seen as a scenario wherein now in the rainy season, few of the malls are keeping some discount. So for example, 25% discount on the purchase of 5,000 or something like that. So in that case, we can also analyze instead of profit or instead of sales, we can also analyze it on the basis of discount. So for example, I am keeping X amount of discount, what profit I am getting. So in that case, I have to take profit, I have to take discount on x-axis because my profit is not going to be an independent measure. It will be dependent on some of the value. So in that case, instead of sales, I can take discount. So for X discount, I am having Y profit. For Z discount, I am having Z profit. So in that case, where we have two major value or two numerical values, we can have a scatter plot. Next, after scatter plot, we have a bubble chart. Now, when we are talking about bubble chart, we are it is also called as packed bubble chart. So as bubbles, now bubbles means nothing but a circular shaped graph that is plotted. Now, for example, I have four regions: east, west, north, south, and I'm having a phone that is Nokia, and I want to find out Nokia is having sales in which region the most, whether it is east, west, north, south. So in that case, I can put the four regions as the four circles, and the size of circle is going to give me a quick insight of if the size of circle of north is the highest, that means the maximum sales is happening in north, and if the size of circle or the bubble is the lowest in east, that means east region is having the lowest sales. So for example, here as you can see, now can you tell me why these colors? We have already seen these colors in heat tree map. Can you tell me why these colors and why, what is the significance of these colors? Anyone please? What does this indicate, this circle? What, how different is it is from other circles? Can anyone tell me?
It has the maximum value, that's why it's darker.
Correct.
And
Yeah.
the size is also bigger.
Perfect. So as you have rightly said, the darker color, that means highest value. So when you see at this chart, your attention automatically draws to the darkest values or to a distinct colors and distinct size. So here, as you rightly said, the binders is the subcategory which is having maximum discount, that is 37%. That's why its shape is largest and its color is darkest. Whereas when we are seeing at the smaller values, as you cannot easily make out because 7% and 8% is just a minimum difference or just minute variation. So I think we can see somewhat similar 1 2 3 4 5 6 7 8 like 8 subcategories that are having closer discount each, that is either 7% or 8%, and average we are having, let's say for example 21%, that is the middle color, that is neither darker not lighter, it is in between, that is 21%. So here to highlight, now you know that it darker color, that means the highest value. So for stakeholder, or now our visualization is not Tableau is not handled by all people which are having knowledge of Tableau. Like when we are giving our project to a client, now client is not a technical person, he can be a salesperson. Now from long time we are talking about sales. So for example, let's say a salesperson is handling this data. Do you think a salesperson will understand what exactly this means? So no. So for ease of understanding, there are some things that are mentioned, like in the map there is a direction east, west, north, south. Now we all are familiar with this, but that is a convention to keep that arrows showing east, west, north, south, or at least north is shown in that like arrow, or doctor's sign is shown outside the doctor's cabin or something like that. So similarly, for ease of understanding, we are showing this color palette. So 7%, that is the red section, is going to show the minimum value, and darkest green section is showing the maximum value. So now the end user can easily understand that the red color is a problematic area and green color is one of the thing that is a good thing, or a good performance. Okay. Next, we have a heat map. Now, heat map means density chart. It is also called as density chart. So here, tree map and heat map are having somewhat similar applications. As in, when we are talking about tree map, we can see the colors and the shape are differentiated, but they are in a continuous manner. That means they are part of a particular whole picture. This block is a part of this particular whole picture. This block is part of this particular whole thing. But in case of heat map, as you can see, they are also blocks. They are also differentiated by darkest to lightest color, but they are discrete. That means they are individual of each other. Now, similar to tree map, where we have shown highest value, darkest color. Now we can see the highest value is darkest color. But here again, we are analyzing two measurable values, that is sales and profit. Sales is indicated by color. That means lowest sale is 3024, highest sale is 33007. So this darkest color will show me the highest value. I can easily locate the highest value. And profit is shown by size. Now these symbols are nothing but sizes. So minus $17,000 is the dot, and $55,000 is nothing but the largest block. Means size is, profit is put in size, and profit is indicated by size, sales is indicated by colors. So here also now we are analyzing different subcategories with the help of two things or two visualization concept, that is color as well as size. So the block that is having the darkest color and the biggest size is nothing but the block having maximum profit and maximum sales as such. So we can see that this block is having sales maximum, that is 333007, and profit as 44156, so 516. But profit is not the maximum, but the sales is maximum for phones. So this can also be easily located with the help of heat map. Now there is always a debate whether to choose tree map or whether to choose heat map. Now, when we are talking about part to whole means what? If we want to show a small part from a particular group, or if you want to show a differentiating small section from a particular complete section, we can go for tree map. And if we want to differentiate all the sections individual of each other, we can go for heat map. Okay. Then we have bullet graphs. Now bullet graphs or bullet chart is nothing but a variation of bar graph. Now let me tell you one thing, bar graph is one of the most used bar charts in visualization in the companies as well. So bar chart or bar graph has multiple use cases. Use cases is nothing but applications or usages in case of Tableau. So it is another type of bar chart wherein it is useful for comparing performance of a primary measure to one or other measure. That is performance of a numeric value. Measure is nothing but primary numeric value to other numeric values. So for example, here you can see a bullet chart wherein when we hover over to this bullet chart, again we are analyzing subcategory wise sales and profit of the sales. But this is the maximum that, for example, percent of average sales. That means this is the average sales. This was the target and this is what we have achieved. Similarly, the dark line shows the target and this is nothing but maximum that we have achieved, or this is nothing but, that means we are having this is our target, sorry, this is our target, and this is the thing that we have achieved. Bullet chart is nothing but the target, and part is nothing but the bullet chart. Next, we are having Gantt chart. Again, Gantt chart is having a use case or application in time series analysis or trend line, wherein the x-axis or the rows are nothing but time period, and the y-axis are nothing but different dimensions or different qualitative values. So, for example, in this sample superstore data, I have week of order date. Now, order date is a parameter, or it is a qualitative field. It is a date field of the year 2016. So here I'm analyzing from Jan 1st to let's say December 31st. But from Jan 1st to December 31st, I'm having a particular shipping application. So for example, I'm booking something from Amazon. So when I'm booking something, it is nothing but my order date, or for example, what I can say. Now, when we are booking something on Amazon for today, for example, and I'm going to receive that product 5 days later. Do you remember that we get messages in between that your packet has been, your delivery has been booked, or then after a few days we say that your delivery has, your product has been picked up from the vendor. Then we get a message after a few days that it is off for shipping, and then finally we get a message that your packet will be delivered today, right? So those particular days, or those particular number of days, or average time period required from booking to delivery, can be analyzed as total number of days, and depending on that we can have a Gantt chart. So for example, this particular ship mode means whether the product is coming from FedEx, whether the product is coming from DTDC or something, courier service we can say. So in this sample superstore, we are having 4 courier services, that is first class, same day, second class, standard class. So different shipping modes. So if I hover over to this block, so this block says that the ship mode or the courier service is standard class. Subcategory that we are using is appliances. So I have booked appliances. A week of order date, that means I have booked it in on May 29, 2016. And average order until ship means for on an average, it is going to take 5 days for delivery. So this particular block. Now, if I hover over to this small point, you can see that again same concept, size variation, that means smallest size minimum value. So you can say that same day. Why the size of this line is so thin? Because delivery has been done in same day. As the number of days increases, the thickness of block increases. Now here you can see the thickness of block is larger because the average comes to 3.000. That means around 3 days. Here it is smaller, it is 2 days, and here it is negligible because it is delivery, as you can see, it is on same day. Now if I'm selecting same day, you can see that there is a thin line. See here 3 thin lines because it did not take much time. I'm selecting first class. Now first class products, the products that are booked through first class are either getting delivered in 3 days, or they are getting delivered in 2 days. If I'm selecting second class, again products are getting delivered in n number of days. And if I'm selecting standard class, you can see it is taking maximum number of days to deliver a particular product. So it is on an average 4 days or more. So this is a colorful chart. We don't know which color indicates what. Every time we have to see over here. Instead of that, for simplicity, again we are giving a color display. Dark blue color indicates the first class, and same day orange, and so on. Okay. Then we have next chart, that is nothing but a box plot. Now, when we are talking about box plot, it is a bit advanced chart. It is also called as box and whiskers. It shows the distribution along x-axis. Now, when we are talking about box plot, so here instead of subcategory, I have taken category versus profit. So in this sample superstore data set, we are having three categories: furniture, office supplies, technology, and their profit. So I can say that now you can observe there is upper whisker, upper hinge, median, lower hinge and lower whisker. So for the time being, you can ignore the whiskers and you can look at the median. Median means on an average, what is the profit of this office supplies? That is 22,734. Similarly, median for technology is nothing but 26,827. Now these small dots are nothing but the ship mode. That means I'm having two two alphabetical field, that is category as well as ship mode. So these dots are nothing but ship mode. We have seen it in previous chart that we are having four ship modes, and those ship modes are again indicated by these four dots. Okay, so this is nothing but a box plot. Then we have waterfall chart. Now waterfall, as the name suggests, if you have seen waterfall, it is nothing but blocks of stones and they are stuck to each other. And when there is during rainy season, the water is starting from highest to the lowest and it is flowing downwards. So similarly, water chart effectively displays the cumulative effect of sequential potential negative and positive values. So for example, let us look at the visualization. So here I am analyzing the data of sales, total sales from the year 2016 to the year 2019. As we have already seen it in line chart, our sales have drastically grown from 2016 to 2019. But at what rate? So in first year, my total sales were 484,247. In the second year, my sales grew and it is showing from 954. Now it is again another type of bar chart. Just that bar chart is not touching the x-axis. It is showing, it is having the size from the top. That means the upper hinge of this bar is exactly the same as lower hinge of the next bar. So it is nothing but a running sum. So running sum means what? So for example, this when we have this value and when we have this value, so this value, this block is nothing but this plus this. Now when we go to 2018, the sales of 2018 is nothing but sales of 2016 plus 17 plus 18. And finally, when we have sales of 2019, is the effect, it is nothing but the effective sum of all the sales from 2016 to 2019. So running sum is nothing but start every next block is nothing but addition of previous block and itself. So this is nothing but waterfall analysis. So this is the one of the most favorite analysis in the industry. Now coming back to one of the chart that we had left for discussion, that is nothing but our I think yeah, we left out Pareto. Now Pareto chart is one of the utmost or one of the most important charts in Tableau. So it is nothing but a combination chart. Now when I'm saying combination chart, it combines both bar as well as line chart. So it is a combination of bar chart and line chart. But the main thing is that Pareto, that is a scientist or engineer named Pareto, he made an observation that 80% of land was typically owned by 20% of population. Now to simplify things, I can say that for example, in a hotel, I'm having, for example, what I can say, I'm introducing a product called as softie, simple softie, chocolate softie I'm introducing. So when I want to find out the total sales of that softie in a particular, say, let's take for example January month. So I can say that softie is having maximum sales because of 20% of the students from coming from colleges. So 80% of sales, that is maximum sales. So Pareto chart is always divided, or it is called as 80-20 chart. Means what? 80% of outcome depends on 20% of root. That means 80% of sales of my softie is dependent on 20% of my crowd. As you can see in this analysis, subcategory wise sales. So I can say that bar chart, simple, maximum bar size, that means maximum sales value, minimum bar size, that means minimum sales value. But as I said, it is a 80-20 ratio. That means out of total sales, my highest sales is being made by phones. Okay, and so 80% of sales is made up by 20% of crowd. So it is exactly inverse. As you can see, 80% and 20%. So the line chart indicates the 20% of contribution and the bar chart indicates the 80% of contribution of that particular category. And again, this line is nothing but the running sum. As we have already discussed in waterfall chart, running sum is nothing but sum of this plus sum of this. Third point is sum of first 2 points. Fourth point is sum of previous 3 points, and so on. So Pareto chart defines 80-20 ratio. That means 80% of output depends on 20% of values. So in the business, you can say that 80% of profit is derived from 20% of available product. So if you want to find out ये मेरे दुकान में मैक्सिमम सेल्स कौन से प्रोडक्ट की वजह से हो रहा है, सो यू कैन फाइंड आउट मैक्सिमम प्रोडक्ट बिकॉज ऑफ 20% ऑफ maximum sales because of 20% of a particular product. So Pareto chart is one of the utmost important chart. It is almost one of the favorite of the interviewer as well. So yeah, so that's it for the day from myself. Thank you so much. Please let me know if you have any doubts.
And guys, if you have any queries, you can ask Avanti.